Hello and welcome to Module 4 in our C language series. In today's session, as you can see on screen, we're going to be focusing on arrays and strings. So let's get right to it. What are arrays? And the definition says a collection of variables of the same data type referenced by one name. Highlighted terms are what are important to remember, and so we could have numbers, one name, representing this collection of variables of the same data type. But how do we access each of these variables separately? The answer is we can use an index. Now, in C, all arrays consist of contiguous memory addresses. And so the lowest address is the first element's location, the highest address is the last element's location. The most common array in C is a string. And so we could have something like this, with each character occupying one memory space or one memory address. And of course, to access each of these characters separately, again, we would use an index. And so we would have str1 of 0 representing H, str1 of 1 representing E, and so on and so forth. Arrays and pointers are closely related. Detailed discussion on pointers in the next session. For today, all you need to remember is a pointer is a variable that contains a memory address. Now coming to single dimension arrays, the type would declare the base type of the array. So that would be character, integer, float, etc. The size would indicate the number of elements in the array. Important points to remember in terms of arrays, all arrays must be explicitly declared. Just like variables, remember the array 2 is a variable and cannot be used without being declared. All arrays have 0 as the index of the first element, as we saw in the previous slide. So if we have an integer array, numbers with 4 elements, the last index would be 3, right? Because the first index is 0. Similarly, if you have a float type array of 100 elements, the last index would be 99. Remember, the last index is always one less than the size or the number of elements in the array. Amount of storage required to hold an array is directly related to its type and size, and so we could use this formula. We have total bytes in the array equal to size of, and we're using the size of operator, the data type, that could be int, char, etc., multiplied by size of array or number of elements. Keeping that in mind, what would be the size in bytes of the following? We know that the char type occupies 1 byte, so that would be 1 multiplied by size of array, which is 10, and therefore this would be 10 bytes. In terms of the integer array, the size of int is 4 bytes on the machine I'm working with, multiplied by size of array 10, that would be 40 bytes. What about shortened? That's 2 bytes, multiplied by size of array would be 10, so that's 20 bytes. And then we have double, the size of which is 8 bytes multiplied by size of array, which is 10. That gives you 80 bytes. And you can verify this through a simple program that I have already written. And so we have the same arrays here. You can see we have a character, integer, shortened, and double array. And then, of course, using the same formula, we are printing the size out. And if we run this, you will see the results are the same. Right? The character array is 10, the integer array is 40, shortened is 20, and double is 80. So I hope that's clear. Any questions? Feel free to post in the comments. Now moving on. There's no bounds on arrays. So we could have code like this where we have an array of size 10 and we're trying to store 100 values in it. Compilation will go through without any error whatsoever. But we could end up with unpredictable results, and therefore it is the programmer's responsibility to provide checks for bounds on arrays. Now let's write some code. Write code to store the first 10 even numbers in an array and print them out. So what are the variables we need? We definitely need to declare the array. We need a counter to count to. We need 10 even numbers, so we'll have to count to 20, of course. And we may need one variable that we will use as what is called a subscript. More about that when we get into the code. So let's go back into code blocks and start a new file. Just going to call that check even, and you can code along with me if you like. That is, we don't have any input here, so hashtag include standard input output dot h, and then int main. Now, as I said, we need certain variables. We need the array. We're going to just have it as a short int type, and we're going to call that even nums. It's going to have 10 elements. We also need a counter, right, to count up to 20. And then, as I said, we need another variable. I'm going to put that in and I'll explain to you what it's going to do. I'm going to call it even counter. So now we can have our loop. We'll initialize counter to the first even number, and we'll initialize even counter to 0. Okay, that's our initialization section. Condition will be as long as counter is less than or equal to 20. Why less than or equal to, you may ask? Because remember, we want 20 included in our results, right? We want the first 10 even numbers, so that would include 20. Then counter plus plus. Now, within this loop, we will need to have the check for even numbers. We did this the last time by using the modulo arithmetic symbol. And so we'll have if counter %2 equal to 0, right? Then we will have to put that value of counter into the even numbers array, right? And so we can say even nums, and this is where even counter will come in. So currently it's 0. And that's what is called a subscript. So we're going to position the value 2 for the first time, right, into the even numbers array at the position indicated by even counter, which is 0. So that will go into the first place equal to counter, right? Counter is 2. Now, once that is done, this particular counter needs to increment. Why? Because it needs to be ready at the next position in the array for the next even number to be placed. And so we'll have even counter plus plus included within this if statement block. All right, I hope you're with me. Again, any questions, feel free to post in the comments. Right, and so this loop will go on. Right, and it will continue as long as counter is less than or equal to 20. Once counter is equal to 20, that's when control comes out of the for loop, at which point we can print out all the even numbers. So we can use any of the counters. Now counter less than, we have 10 elements, and counter plus plus, right? This 10 elements refers to the size of the even numbers array. We don't need a block because we're just printing out the even numbers. So printf %d, we can leave some space, comma, this should be hd, right, because it's a short integer, comma, even nums of counter, right? That's the way we access each element in the array using this subscript, right? So in this for loop, even counter serves as a subscript, right? Or you can call it the index if you like, and here counter serves as a subscript or the index. Okay, so now we can run this, and you can see we have all our even numbers printed out, right? And that's 10 of them. Moving on. Write code to calculate and store the squares of the numbers 2 to 10 in an array and print them out. We know how to find out the squares using the pow function. Again, we will need an array. That will be our variable. We will also need two counters. As you know, one will be required in order to help us position these numbers in the squares array. So let's now go back to our code blocks and start a new file. I'm going to call it store squares. So now again, hashtag include stdio.h. We don't have any input, so we don't need any other header file as such. Int main, variables that we need is going to be the squares array, and that's going to be short int squares. How many elements would we need? We have from the number 2 to 10. So if we include both 2 and 10, that would be 9 elements. We need a counter, right? That will help us count through from 2 to 10. And we need another one to help us place the values into the array, which will serve as the index or the subscript. So now we can have our for loop initialize counter to 2 and square counter to 0. Hope you know why we are initializing square counter to 0, right? Because remember, the first index is always going to be 0. And then we have counter less than equal to 10 counter plus plus. Within this loop, what do we do? So here we can say squares of square counter. We're directly placing the value into this array equal to. And now we know that pow requires doubles of floats, right? So what we're going to do is we're going to use casting. So we'll cast it to short int. And then we'll say pow pass in counter, comma, 2 as the pow. Right? Then square counter now needs to increase by 1. So again, within this loop, we are directly placing into the array at the position indicated by square counter the square of the number, right? And then of course incrementing square counter by 1 so that the next time square counter is 1 and we position the value in the second place, and so on and so forth. Once we are out of this for loop, which will be when counter is no longer less than equal to 10, then we can proceed to print out the squares. So for counter equal to 0, right, starting at the first index, counter less than 9, right, counter plus plus. And then of course we just print percentage HD, comma, squares of counter. Again, I hope you're with me. Right, we're just printing out squares at the position indicated by counter. So this is our index or subscript. First it will be 0, 1, 2, 3, 4, etc., etc. Right, now if we run this, okay, we have a warning here. Why do we have this warning? Because we haven't included math.h. And we saw the output was a little crowded. So let's put a space there. Let's run this now. And you can see we have all the squares nicely printed out, right, from 2 until 10. Okay, moving on. Write code to calculate and store the cubes of the numbers 2 to 10 in an array and print them out. I'm not doing this one. I'm sure you'll be able to manage it. It's the same code. You're just changing that to cubes. Write code to accept the salaries of 20 employees, deduct 20% as tax, and store the net salary in an array. So again, the variables that we need would be 1, a counter to count the 20 employees. We need an array to store the net salary. We need 2, have a variable salary because we will ask for it to be input. Right, so let's go back to code blocks. Let me start a new file. Let's call this store salary. And hashtag include stdio.h. And we're using scanf, so hashtag include stdlib.h. And int main. Now let's declare all variables. So we need, let's keep this as integer because salaries could be any amount. So integer net salary. This is going to be the array of 20 elements as we have 20 employees. Then we need salary that we're going to have input, right? And we need a counter to count to 20 employees. Right, now the next step is, of course, to have our loop and then accept the salary, calculate the net salary. So for counter equal to 0, counter less than 20, we're not going to say equal to 20. Why? Because 0 to 19 would be 20 elements, right? So counter less than 20, counter plus plus. And within this loop, we'll have our printf statement. Please enter employees salary. Leave some space there. And then scanf %d, comma, ampersand, salary. Right, now we got to do the calculation. So we'll say here, net salary at the index counter equal to, so remember this will be 0 for the first time, equal to salary minus, we've got to deduct 20%. So salary multiplied by 0.2. Note how we use the brackets to make sure that this is done first, right? This calculation, and then is subtracted from salary. Why 0.2? Remember 20% is 20 upon 100, which is 0.2. That's all. So this loop will continue as long as counter is less than 20. The moment counter is not less than 20, we're going to come out of this for loop, which will bring control here, and we can print the net salary. So for counter equal to 0, counter less than 20, counter plus plus, and we'll just printf %d, comma, net salary of counter. Right, so I hope that's clear. We can also leave a space here so that we have some space between the different net salaries. Now I have a question. Are we going to test this 20 times? Right, so that's a kind of waste of time for us. What we'll do is we'll test it with 5 employees. If it works with 5, it should work with 20. And this is what you will do in the real world as well. You're not going to sit and put in thousands of entries just to test your program. You're going to test it with a smaller number. Right, so now let's run this. Enter employee salary. Sometimes this window is not active, just click on it. 5,000. Enter another one, 3,000, 40,000, 60,000, and let's say 6,000. Right, now you can do the calculation. 5,000 less 20% is 4,000. Yeah, because 5,000 into 1 upon 5, that would be, right? So 5,000 minus 1,000, so 4,000, that's correct, and so on. Okay, moving on. We need to now talk about strings. What we've seen are one-dimensional arrays. Now, strings, as we know, are one-dimensional arrays terminated by a \0. This is important. Character arrays are therefore declared one character longer than the largest string they will hold. Now, here's something to remember. When we're using scanf, it will automatically place a \0 into the string. That's done by the compiler. We don't need to put it there. But if you're using, for example, getChar, right, then you will have to put the \0. Okay. Now, what would be the declaration for an array that holds a 20-character string? So that's the maximum number of characters that can be held. We would declare it as 21, just to make space for the \0. What's important to remember is that we do not need to add a null to the end of string constants. What's a string constant is when we are defining the contents of that string within our program. Okay, so for that constant, again, we don't need to put in the \0 or the null as it is called. Write some code, write a program to print the number of vowels in a sentence. Now, the first time the sentence is going to be a constant string. So let's go back to code blocks. We start a new program, check vowels. Right, so hashtag include cdi.h. We are not asking for any input. Remember, the string is going to be a constant, and so we just start with int main. What are the variables that we need? We need that constant string. Of course, that's going to be an array. So we're going to say here character str1. That's the syntax, equal to, that's going to be our constant string. Right? Now, what else do we need? We need a counter that will count through this string, right? And then we'll need one that will be able to add up the number of vowels. Remember, our output should print the number of vowels. So we'll have short int counter, and we'll have something called a vowel counter. Now we'll have 4. Let's initialize both these counters equal to 0. Vowel counter equal to 0. What's going to be our condition? We can say as long as str1 of counter is not equal to null or \0. So as long as str1 at the position indicated by counter does not contain a null, this loop will continue. And here, of course, counter ++. Now within this loop, we need to do the check for vowels. So we can say here if str1 of counter equal to, again we're using the relational equal to operator there for comparison. So equal to E, or, and now we can just copy this to save time. and then change it accordingly. Or, so if it is any of the vowels, then vowel counter should be increased by 1. Right? Once that condition is no longer met, we'll get out of this loop and we can then print the number of vowels. So printf, the string as %hd vowels, comma, vowel counter. It's important to name your variables meaningfully. Right? So somebody reading your code knows what your program is doing. I hope you've understood this code. We have these two counters. One is adding up the vowels and one is just taking us through every character in the string. Right? So let's run this now. The string has 18 vowels and you can count those. Moving on now. Modify the previous program to allow the user now to enter a string. Again, we're going to use scanf here, so we don't need to put in that null or \0. Right? It's going to be done automatically. So instead of using a constant now, we can comment this line out. Right? We have the same variables, but here we will say printf enter a string of up to 100 characters, in which case we've got to also define our or declare our array. So let's do that here. We can say character str1 of 101. Right? Now, after the printf, we'll have to have a scanf here. Scanf %s. Do we need to use the ampersand? No, we don't, because remember, the name str1 itself is the address of the first element in the array. So str1. Okay. Then, of course, the logic will remain the same. So let's run this now. Again, activate that window. Let's put in the same string. Okay, now it says a string has one vowel. Why is that? So let's do one thing. Let's print the string here. Printf %s, comma, str1. Now if we run this, enter the same string, you can see it's just taking all. And that's because scanf stops accepting input when it encounters a space. So everything else is lost. How do we avoid that? We can use a pattern here. We can say box bracket until a \n is entered. Continue accepting input. Okay. So now we don't need this printf. I'm just going to take it off. Let's run this again and see what happens. So now let's put in the same string. And there you have the string has 18 vowels. Right? So moving on now. String manipulation functions. Right, so we have string copy. This will copy string 2 to string 1 as is mentioned on screen. What's important to remember is that string 2 will retain its contents while overwriting the contents of string 1. String cat will join two strings. String 2 will be joined to string 1. The string len is pretty straightforward, returns the length of a string. String compare returns 0 or false. That's important. If string 1 and string 2 are the same, returns less than 0. If string 1 is less than string 2, returns greater than 0. If string 1 is greater than string 2, and that's dependent on the alphabetical order, as we will see shortly. All the above use the file string.h, and that's important to remember because we need to include this header file when using these functions. So let's go ahead and take a look at a short program that will show us how these functions work. So we have string 1 that has hello, string 2 world, string 3 string, and string 4 compare. Note that I have just sized up this one, right, because I'm going to use it in the string cat function, right? So there needs to be place for string world to be concatenated to hello. So let's run this now. String 1 is world and string 2 is world. That's happened after the string copy. So you can see that string 2 has retained its contents while overwriting the contents of string 1. The concatenated string is world world. String compare returned a 1 because S is greater than C, right? Then we have the length of string 1 after concatenation is 10, right? 5 plus 5, 10. Now talking about string compare, what if we had to switch these around? So let's say we have here compare and here we had string. Now if we run this and we just look at the results of string compare, you see return -1 because C is less than S, right? So now moving on. Write your own version of the string copy function. We know how the string copy function works. Can we write our own version? Let's go to code blocks again and start a new file. So we're going to have string constants. We're going to be accepting strings here from the user. And then we'll have our int a. Right, within this, we'll have our constant string. So char str1 equal to hello and str2 equal to world. So how do we do this? We'll have to take each of these characters and move them here, right? So we'll have a counter there, short int ctr, that will serve as an index for ctr equal to 0. Now, since we're copying this string to this one, we look out for the end of the string. So str2 of ctr not equal to \0. And then, of course, ctr plus plus. And all we need to do here is say str1 of ctr equal to str2 of ctr. And that's all. And then outside this, we can just print the two strings. So printf str1 is now %s and str2 is now %s, comma str1, comma str2. Let's run this now, right, and see if we have written our string copy. And you can see str1 now is world and str2 is also world. You can also write your own string cat or string concatenation function. Right, moving on. Write a program to print a string in reverse order. So let's call this rev string hashtag include stdio.h and then hashtag include, let's ask the user for a word, stdlib.h and hashtag include string.h int main, and here we'll have char str1 of, let's say, 20. So this is going to be one word, right? We're going to ask the user for that one word, and we'll need a counter, right? So short int counter. Let's start with those two and see if we need any more. Right, so after this, we need to get one word from the user, but we need to make sure that the user is entering exactly one word, right? So let's put that in a loop while one, meaning while true. And here we say printf, enter a word of max 20 characters. Let's make this 21, right? Then scanf %s, comma, str1, right? Remember, scanf will stop at a space, and that's fine for this particular program. We check here if strlen of str1, right, is greater than 20, right? So you can have this put into brackets as well. Then we can print out a message to the user. Your word can only be of 20 characters. And then continue. So of course that's a code block that we have here now. So we can put that into the curly braces, right? Else we'll just break out of this while loop, right? That will bring us here. Once we are out of the loop, we can then proceed to print in reverse order. How do we do that? We can have a variable here. Let's call it string length. And again, we can use string length to store the result of strlen of str1. Now that we have the length, we can say for counter equal to string length -1, right? Because string length will give us a length in terms of the number of elements in the string. -1 would give us the last index. -1, then counter greater than or equal to 0, right? Then counter minus. Right? So we're going backwards. And then we will just printf %c, comma, str1 of counter. Right? And that's all. So let's see how this works now. Let's run this. Let's say language, and you see it's printed out in reverse order, right? Moving on. Two-dimensional arrays. So two-dimensional arrays are the simplest form of a multi-dim array. It's stored in a row column matrix, so you could have something like this. The row runs horizontally, the columns vertically. And of course, as indicated here, we need two subscripts or two indices, right? The bytes taken by this two-dimensional array would be size of first index, so that's 3, multiplied by size of second index, that's 4, multiplied by size of the base type. So this is integer, this would be 12 fours are 48 bytes. What's important to remember is that the first index relates to the rows and the second index relates to the columns. So if I have to access this value, for example, I would take row 0 and then column 0. Similarly, if I have to access this value, it would be row 0, column 1. If I have to access this value, it would be row 0, column 2. And then row 0, column 3 would access this value. Similarly, in the second row 1, column 0 would access 5, row 1, column 1 would access 6, row 1, column 2 would access 7, row 1, column 3 would access 8. Right, so I hope you get the idea. Write a program to store grades for each student in a class. Assume the teacher has 4 classes and a maximum of 40 students in each class. So we're going to have a two-dim array here with rows indicating classes and columns indicating students. So let's go ahead now and write that code. I'll start a new file. Let's call this store grades and save. Hashtag include stdio.h and then hashtag include stdlib.h because we are accepting the marks from the user. Int main, and here what we need is to first declare the array. So we call it marks. It's going to be of shortened type and it's going to have 4 classes and 40 students, right? We also need now 2 counters. Remember, we will need 2 indices, so we call them one class counter and student counter. We start with these 3. We'll see if we need more. Now we have our for loop. We will need one for loop to count the rows and one to count the columns. So we start with the rows first. That's the outer loop. So for class counter equal to 0, class counter less than 4, class counter plus plus. And within this loop, we can print the class number. So class number percentage HD, comma, this would be class counter. But remember, class counter starts from 0 and we don't want 0 to be printed out here. So we just say +1. And that works for us, right? So first time will be 1, 2, 3, and so on. Now within this, or rather after this, we need another loop. So for, and this will be for the students. Student counter equal to 0. Student counter less than 40. Student counter plus plus. And within this inner loop, we will ask the user to enter the marks. So printf enter marks for student percentage HD, right? And we can leave a space there, semicolon. Now after this class number, maybe we have a new line, right? So that this message comes in the next line. And then scanf percentage HD, comma, now we're going to use the array, marks, and we will use it to indices. So class counter and student counter. Now because we are directly accessing the value, we need to use the ampersand. Okay. So we're directly putting in the value into the position indicated by these two indices, right? So this loop will go on as long as student counter is less than 40. When student counter is no longer less than 40, it will go into the outer loop and increment class counter by 1 and again repeat the loop for students. So you can see this inner loop increases faster because the outer loop will increase only after entering the marks for 40 students, right? Or after this one has incremented 40 times. Now, once these loops are done, we can then print out the marks for the students. And of course, we need to be out of both the for loops. So that would be, yeah, right? And here we say for. Again, we can use the same counters because we need to have two loops here as well. Class counter less than 4. And you can leave a space if you like for easy readability. Class counter plus plus. And then within this loop, we can again print the class number. \n, comma, class counter plus 1, right? And then we have for student counter equal to 0, student counter less than 40, student counter plus plus, and within this loop we can printf marks for student percentage HD are percentage HD, and then we can have comma student counter plus 1, comma, and we have to print the marks, so marks, and then we put in the two indices, so class counter and student counter. So I hope you're clear with this. Of course, we could have each student's marks printed in a new line, so you can add that new line character there. Semicolons to be put wherever needed, right? So I hope you've understood this. When we're having two dimensions, we need two for loops. The outer for loop will control the rows, the inner for loop control the columns. Now, instead of testing this with 40 students, what we can do is we can test this with 5 students. Right? Make sure all braces are matched. And now we can run this. Okay, what is that minus 1488? Let's go check that. Okay, so here we've forgotten to put in the student counter plus 1. Right? Now let's run it. So let's say 78, 87, 98, 89, 76. Next class, 100, 98, 78, 97, 68. The third class, 90, 89, 100, 98, 89. Fourth class, 78, 89, 90, 100, 87. And now you can see the marks are printed out as well. Right? So I hope that's clear. Moving on. Arrays of strings. Now we're talking about two-dimensional arrays, but of strings or string type. Size of the left index determines the number of strings, and size of the right index specifies a maximum length of strings. And so we could have char fruit array where we have 3 rows and 8 columns, meaning there's going to be 3 words and each word is going to be 8 characters at the maximum length. Right? And so you can see here we have 3 rows and we have 8 columns. What's important to remember with arrays of strings is that we can just use the row index to access the entire string. Right? So if we say root array of 0, this would give us apples. If we say fruit array of 1, that would give us the entire string oranges. And if we say fruit array of 2, that would give us the entire string mangoes. Right, so now let's go and write some code. Write code to accept 10 names of employees and store them in an array. Let's go back to code blocks and we start a new file. Store emp names. Hashtag include stdio.h. Hashtag include. You're going to get names in from the user, so stdlib.h. Then int main. We got to declare the array. So char emp names. That's going to be 10 names. And let's have them at 30 maximum length. So now we need, of course, a counter. So we just have short int counter. And let's start our loop for counter equal to 0, counter less than 10, counter plus plus. Within this loop, we'll printf enter employees name. And then scanf. Now string two-dimensional arrays are easier. What we can just do is we can say %s, comma, and we can say emp names. But since this is a two-dimensional array, we'll use one dimension here and say emp names of counter. Note that we don't need 2 for loops. We're just using the row as such in order to put in the names. And so we could call this row counter just to make that clearer. Remember that in one-dimensional string arrays, we were directly putting the array name. Now, because there's 2 dimensions, we need to specify the one dimension, which is the row. Therefore, you can think of two-dimensional string arrays as being a group of one-dimensional string arrays, right? Okay, now that we've done that, this will go on 10 times. We can then just print them out. So here we can say for, and we can use the same counter, row counter equal to 0, row counter less than 10, row counter plus plus. And within that, all we need to do is printf %s \n comma emp names of row counter. Right? So now let's try with 5 instead of 10 employees. Right? If it works for 5, this program works for any number. So let's see now. Jane Eyre. Now you can see I'm getting this prompt so many times. And just as we did in getChar, what we can do here is say f flash stdin. Also, if we want a space in names and we can't just say %s, what do we need to do? We need to say accept any character except the \n. So stop accepting characters once a \n is entered. Right? After making those two changes, run it. And let's say Jane Eyre and Robert Frost. And let's say Helen Troy and Anne Frank, and James Burns. And you can see all those names are nicely printed out. Right? Moving on. Multi-dim arrays. C allows arrays of any dimension. Right? But the exact limit is determined by the compiler. General form would be type, right? Whether it's int, char, etc. The name of the array followed by the dimensions going up to any number as determined by the compiler. But having said that, arrays of 3 or more dimensions are not often used. Why? Because they take up too much memory. Now coming to array initialization, initializing a single dim integer array with constants would be something like this. Okay, that's an integer array initialization. Initializing a single dim string array with constants would be something like that. It's the same as doing something like this, but of course, this is not really recommended. Again, initializing a double dim integer array would be something like this. Right? Talking about unsized array initializations, we could initialize string arrays like this, putting in the size, but we could also initialize them without the size, and this is actually recommended. The advantage is that we can change these error messages without having to worry about the dimension or the size. So this ends our session for today. In the next session, we will be talking in detail about pointers. Till then, take care, stay safe. Bye.